Well, hello, fellow YouTubers. Welcome to yet another episode of G-Tech. We're at the finish line regarding the upgrade of the Phase Linear 400 Series 2 amplifier. In this episode, we'll get into the adjustment, testing, and performance of this amplifier. If you enjoy these episodes, hit the like button, comment, and subscribe. Well, let's get right into it.
Warning. Do not attempt this project unless you are experienced with electrical circuits. Serious injury, property damage, and even death can occur with this wire.
Here, under item 6-5.1 A, B, and C, it specifies a procedure for properly adjusting the bias to ensure optimal performance and low distortion. I'm starting with the left channel. The recommended bias is between 350 and 400 millivolts. I've decided to set it right in the middle, exactly 375 millivolts, to ensure stable operation. Now for the right channel. Keep in mind I've already followed the instructions in point A of the service manual. I've allowed the amp to warm up under load for at least 5 minutes. Again, I've set the bias to 375 millivolts. Both channels are now balanced and within spec. Next, I move on to offset measurement. According to section 5-6 of the manual, the goal is to verify that no significant DC voltage is present at the output when idle. Here's the reading for the left channel, 0 volts DC. That's exactly what we want to see. And the right channel also reads 0 volts DC. Offset is perfect on both sides. Now I'm referencing section 6-1.4 A, B, and C for the current share test. For this procedure, I apply a 200 kHz sine wave at 40 volts into an 8 ohm load and then reduce the AC line voltage to 75 volts. The emitter voltage across the output transistors should read between 190 and 230 millivolts and be within 20% of each other. As you can see, I've set the output of both channels to 40 volts and I'm reducing the AC line voltage to 75 volts, just as the procedure describes. Now, measuring across the emitter resistors of the left channel, transistors 1 through 3 are between 191 and 197 millivolts. Transistors 4 through 6 are between 193 and 196 millivolts. That's well within tolerance. On the right channel, transistors 7 through 9 show between 195 and 198 millivolts. And transistors 10 through 12 are between 199 and 201 millivolts. Again, comfortably within spec. The current sharing test passes with flying colors. Next, for section 5-8, I prepare to calibrate the Cylon LED output meters. The manual states to drive the amp with no load, set the output to 40 volts, and adjust the meters to read 0 dB or 200 watts. Now that I've set up the correct signal level, let's adjust the right channel meter to read 0 dB. Here we go. And now, let's do the same for the left channel. After setting 0 dB, the manual instructs us to reduce the signal to minus 20 dB and confirm both meters track equally. Here, I'm lowering the signal to minus 20 dB and verifying both meters respond identically. Everything is in sync. With both 8 ohm 1000 watt dummy loads connected, we're ready for a power test. I'm slowly increasing the input signal, and we've just passed 45 volts output on both channels right before clipping. That's well over 250 watts per channel into 8 ohms. Impressive. I've set the thermostat for the fans to 50 degrees Celsius or 122 degrees Fahrenheit. Here's the amp under load. As the temperature rises, you can see the thermostat kick the fans on at 50 degrees Celsius. Once I remove the signal and allow the amp to cool down, the fans shut off again once the temperature drops below 50 degrees. The thermal system is working exactly as designed. To finish up, I installed brand new rubber feet properly riveted to the bottom plate. The original feet were adhesive backed and had fallen off. This is a much more durable solution. That's it. We're finished with the amp. Now let's do some listening tests. have to apologize about the audio quality of those two demos. The camera was in the hallway looking into the coat closet where my home theater system is. The amplifier was driving my 4-ohm subwoofers, and it was peaking into the 400-watt region. That caused a lot of rattles from picture frames to air conditioning vents. Well, you can see that the amp is rock solid, it sounds good, and it looks good as well. Well, that'll do it for this whole series of episodes on the repair and upgrade of the Phase Linear 400 Series 2 amplifier. Again, if you enjoy these videos, hit the like button, comment, and subscribe. And we'll see you on the next episode. It's a wrap!